Yung magnitude and direction of the resultant velocity can then be found with the Pythagorean theorem. And i-inverse tangent na lang natin yung function nung final velocity at y over final velocity of x. In our previous lecture videos, we showed that the total linear momentum of a system is conserved when the system is isolated kapag walang external forces na nag-a-act dun sa system na ino-observe or kinakalculate natin. For a general collision of two objects in three-dimensional space, yung conservation of momentum principle implies that the total momentum of the system in each direction is also conserved. However, in this lecture video, merong important na part yung collision na nag-occur lang sa plane surface. At yun yung tinatawag natin na collisions in two dimension. In this tutorial video, we restrict our attention to a single two-dimensional collision between two objects that takes place in a plane surface, and i-ignore na natin yung any possible rotation. For such collisions, we obtain two component equations for the conservation of momentum. For the momentum conservation na nag-occur in the x direction, kapag gagamit tayo ng coordinate system, this equation, and kapag sa y component naman, this equation here, yung merong subscript na y. So we must use three subscripts in this general equation to represent respectively. Number 1, yung object in question or yung object na in-observe natin. And yung number 2, yung initial and final values of the components of the velocity. In other references, yung collisions in two dimensions ay simply tinatawag as the glancing collision. So dahil nasa two-dimensional collision sa tayo and meron tayong x and y component, i-consider na natin yung directions ng objects in terms of their angles. And again, take note that if the two-dimensional collision is elastic, we can write the third equation, yung equation from the conservation of energy. And if the collision is inelastic, the kinetic energy of the system is not conserved. Hindi natin pwedeng i-apply yung conservation of energy. Say for example, we have two objects, object A and object B. Si object B ay at rest lang. Ang merong motion is si object A. Say this is the velocity of A initial, yung red na arrow na yan to the right. So this is before the collision. So for example, ito yung ating signs. This is a positive signs, right of x and the upward y. After the collision, i-consider na natin yung angles nila. For example, this is angle theta and this is angle beta na lang. Si object A napunta in this direction and yung kanyang velocity is wala na directly sa x component or sa y component. With an angle na yung kanyang velocity. Say this is the velocity of A final. And kukunin na natin yung kanilang components. Velocity of A final, cosine theta, and this is velocity of A final, sine theta. Same with the velocity of object B. This is the velocity of B final. So dito, velocity of B initial, this is 0 kasi considering naka-rest yung object B natin before the collision. After the collision, same with the object A, kukunin na rin natin yung kanilang components. Since wala na directly sa horizontal or sa vertical component yung velocity. Velocity of B final, cosine beta, and this is velocity of B final, sine beta. So like sa mga ibang quantities na na-discuss na natin from the previous topics natin, basta two-dimensional, laging mag-occur na dyan yung x and y components together with the angles. We also have steps in solving two-dimensional collisions. Number 1, 2, 3, 4, and 5. Example number 1, vehicle A with mass of 1,500 kilograms traveling east with a speed of 25 meters per second collides at an intersection with vehicle B with a mass of 2,500 kilograms traveling north with a speed of 20 meters per second. Find the magnitude and direction of the velocity of the wreckage immediately after the collision. Assuming that the vehicles undergo a perfectly inelastic collision and assuming that friction between the vehicles and the road can be neglected. For this problem, since yung collision is perfectly inelastic, we only use the conservation of momentum in 2 dimensions. Hindi natin gagamitin yung conservation of energy equation since the kinetic energy is not conserved. Pipili tayo ng coordinates. So using those coordinates, before the collision, the only vehicle having momentum in the x direction is the vehicle A, while yung vehicle B naman carries all the momentum in the y direction. After the inelastic collision, both of the vehicles move together at some common speed. Say, final velocity lang ilalagay natin doon. And an angle theta. So, yung dalawang quantity na yan ang isa-solve natin for this problem using the two components of the conservation of momentum equation. So, draw natin yung dalawang vehicle. Say, this is vehicle A, top view. And eto si vehicle B na papunta sa north. This is our coordinate system. X and Y. This is the positive sides. Vehicle A is traveling at 25 meters per second with a mass of 1,500 kilograms. Patravel siya sa east or positive x direction, and si vehicle B naman is patravel pataas dahil north with a speed of 20 meters per second. Dahil sa north siya nagka-travel, positive y direction yun. First step, gagamitin pa rin natin yung conservation of momentum. Initial momentum is equal to final momentum. We find the x components of the initial and the final momenta. For the initial muna, at x component, initial is equal to mass of A times the velocity of A. So, siya lang yung nasa x component. We have 1,500 kilograms times yung kanyang initial velocity. Say, ilagay natin as initial. 25 meters per second. Initial momentum at x is equal to 37,500 kilograms meters per second. So, ito yung initial momentum at x. Final momentum at x. So, dun sa final, say nag-collide na sila. Ito yung ating coordinate system. Ito si vehicle A and ito si vehicle B. After the collision, nung nagbanggaan na sila, say ito na silang dalawa, ito na yung kanilang direction with an angle theta. And since nagdikit na sila, perfectly inelastic collision, yung velocity ni vehicle A and velocity ni vehicle B final after the collision ay iisa na lang. Kaya nga ilalagay na lang natin as the final velocity, and that is the velocity after the collision. And since nagdikit na sila, yung kanilang masses, pagsasamahin na lang natin. So sa final momentum at x component, pagsasamahin na natin yung mass ni A plus mass ni B, and then multiply natin sa final velocity. Ito siya. Since x component lang hinahanap natin, kukunin natin x component ng kanilang final velocity. Ito yung final velocity at x, and ito yung final velocity at y. At x ito. So, expand natin yung equation. Final momentum at x is equal to mass A plus mass B times the final velocity cosine theta. Ito yung ating equation for the final momentum at x component. Substitute natin yung value ng kanilang mass. Final momentum at x is equal to, ang mass ni A is 1,500 kilograms plus mass ni B 2,500 kilograms. Final velocity cosine theta, this is equal to 4,000 kilograms. Final velocity cosine theta. At y component naman, initial momentum at y component is equal to, before the collision, ang nag-aak lang is si vehicle B lang sa y component. So this is mass of B times the velocity of B initial. Ang mass ni B is 2,500 kilograms, and ang kanyang velocity initial is 20 meters per second. by calculating ang initial momentum at y is equal to 50,000 kilograms times meters per second. Final momentum naman at y component, again, i-consider na natin itong final momentum, yung momentum after the collision. And since isa na lang kanilang velocity and same process with the final momentum at x, itong sinolve natin na to, combined na yung kanilang masses, mass of A plus mass of B, times the velocity final. Pero, ang i-consider na natin dito, since y component is ito, yung final velocity at y component. So, this is mass A plus mass B times final velocity y sin theta na ang ilalagay natin dito. Substituting the values to simplify the final momentum at y component, mass A plus mass B is 4,000 kilograms ulit times final velocity sin theta. Ito na equation natin for the final momentum at y component. To apply the conservation of momentum, let's use this equation here. At x component, initial momentum natin is 37,500 kilograms meters per second is equal to 4,000 kilograms final velocity cosine theta. And sa y component naman, we have 5,000 kilograms meters per second equals 4,000 lang din kilograms final velocity sine theta. To solve for the angle, tangent theta is equal to 50,000 kilograms meters per second divided by 37,500 kilograms meters per second. So, pwede natin i-cancel ito and yung dalawang zero nila para makalis. Theta is equal to inverse tangent times 500 divided by 375. Theta is equal to 53.13 degrees. And since alam na natin yung theta, pwede na natin gamitin any of this equation. Pwedeng equation na to or pwede ring equation na to so solve for the final velocity. So, ang gagamitin na lang natin is yung equation na na-derive natin from y component, 50,000 kilograms meters per second equals 4,000 kilograms times final velocity sine theta. Solving for the final velocity, we divide both sides by 4,000 kilograms sine theta. Dito rin sa kabila, sine theta, cancel. Final velocity is equal to 50,000 kilograms meters per second divided by 4,000 kilograms sine 53.13 degrees. By calculating, ang final velocity is equal to 15.63 meters per second. So this is the final velocity with an angle of 53.13 degrees. It is also possible to first find the x and y components, yung final velocity at x or pwede ring final velocity at y, of the resultant velocity or yung total velocity na tinatawag natin. Yung magnitude and direction of the resultant velocity can then be found with the Pythagorean theorem. Pwedeng ganun. And i-inverse tangent na lang natin yung function nung final velocity at y over final velocity of x. Setting up of this alternate approach is a simple matter of substituting the, say, yung final velocity of x component is equal to final velocity cosine theta, and yung final velocity naman at y is simply the final velocity sine theta. So this is example number 1. Example number 2. A girl tosses a 110-gram fruit toward a boy with a speed of 0.97 meters per second. A bigger fruit with mass of 150 kilograms is tossed from the boy to the girl with a speed of 1.43 meters per second. The fruits collide, sending the heavier fruit off with a speed of 1.2 meters per second at an angle of 38 degrees with respect to its original direction of motion. Calculate the final speed and direction of the lighter fruit assuming an elastic collision. Provide the fruit's direction relative to its original direction of motion. For example, before the collision, this is the 110 gram fruit and ito yung isang fruit. Before the collision, ito yung velocity ni fruit A and this is fruit B. Ang velocity ni fruit A 0.97 meters per second while si fruit B naman 1.43 meters per second. After the collision, nagtama sila at this point and then nag-separate din sila agad. This is an elastic collision. Eto na si fruit A and eto na si fruit B. Ang direction ni fruit A is ganito. Meron na siyang final velocity of A, and merong angle na, say, theta. And si fruit B naman, papunta na siya sa direction na to with a velocity of 1.2 meters per second. And meron siyang angle na 38 degrees from the negative x-axis. Say, ito yung coordinate system natin and ito yung kanilang velocities. So in this figure, we choose the positive x direction to be the initial direction of motion of the fruit A. Before the elastic collision, initially, yung fruit A ay nagmo-move in the positive x direction. Ito siya. With a speed of 0.97 meters per second. And yung fruit B naman ay nagmo-move to the left in the negative x direction with a speed of 1.43 meters per second. Since yung fruit A and fruit B, initially, before the collision, ay parehong nasa x direction, wala tayong momentum in the y direction. After the collision naman, nag-move na yung fruit B with a speed of 1.2 meters per second and meron siyang angle na 38 degrees pababa below sa negative x-axis. And as a result, yung fruit B ngayon nasa momentum in the negative y direction. Meron ng momentum sa y direction. And to cancel this y momentum, yung fruit A must move in the direction that is above the positive x-axis. And ito nga siya. So we need to find first the speed of fruit A by demanding that the initial and final kinetic energies be the same. I-apply natin dito yung conservation of energy since elastic collision ang pinag-uusapan natin. Next, we find the angle by the conservation of momentum in either pwedeng sa x or pwedeng sa y direction. The results are the same whichever direction is chosen. So to find the final speed of the lighter fruit, yung mas magaan na fruit, which is the fruit A, we use the conservation of energy. KE initial is equal to KE final. For KE initial, this is 1/2 mass A VA square plus 1/2 mass B VB square equals, ang final natin is 1/2 mass A VA final square plus 1/2 MB VB final square, or pwede rin namang prime na lang ilalagay natin as pamalit dun sa subscript na final or yung F. Let's derive first the equation to solve for the final velocity ng fruit A. Ito yan. So we have 1/2 mass A velocity of A final square equals 1/2 mass A velocity of A square. Ito yun. Plus 1/2 mass B times the velocity of B square, ito yun, minus, ito na yun, 1/2 times mass B, velocity of B final square. Multiply natin both sides by 2 para makancel ito, and we divide both sides by mass A. So we have velocity of A final square equals, makakancel na rin lahat ng 1/2 dito. We have mass A, velocity A square, plus mass B, velocity B square, minus mass B, velocity B final square. divided by mass A. So to solve for the final velocity of A, we take the square roots of each side of the equation para makancel ito. Velocity of A final is equal to the square root of, let's substitute the values na agad. Ang mass A natin is 110 grams or in kilograms, 0.11 siya. 11 kilograms times the velocity of A initial, 0.97 meters per second quantity square, plus mass of the fruit B is 0.15 kilograms times the velocity of B, 1.43 meters per second quantity square, minus ang mass ng fruit B again is 0.15 kilograms times final velocity niya, we have 1.2 meters per second quantity square, all divided by mass A, 0.11 kilograms. By calculating, final velocity of A after the collision is equal to 1.33 meters per second. To solve for the direction of fruit A after the collision, gagamitin na natin yung momentum. And ang gagamitin na lang natin is yung conservation of momentum at the y component. Ang initial momentum at y component is equal to the final momentum at y component. Mass of A times the velocity of A plus mass of B, lagay natin as y, mass of B times velocity of by equals sa final naman, mass of A times the velocity of ay final plus mass of B times the velocity of B, y final. Again, take note that wala tayong momentum sa y direction or sa y component before the collision. Ito, nasa x direction silang lahat. Therefore, zero pareho yung dalawa na yan. And take note that yung momentum ng fruit A, ito siya, is in the positive direction. While yung fruit B naman is in the negative direction. So, ilalagay natin dito as negative. So, we have mass of A times the velocity of ay final equals, nilipat na natin siya sa kabilang side of the equation para magiging positive na siya, mass of B times the velocity of B, y final. So, expand na natin yung equations, mass of A times the velocity of A final na to, y as sine, hindi natin alam yung angle ng fruit A kasi yun yung hinahanap natin. So, this is sine theta na lang, equals mass of B, velocity of B final, sine, we have 38 degrees. Ito yan. Solving for the theta, we divide both sides by mass A times the velocity A final, mass A, velocity A final, para makancel ito. Sine theta is equal to mass of B times the velocity of B final, sine 38 degrees, divided by mass of A, velocity of A final. Angle theta is equal to inverse sine times, substitute na natin yung values nito. Ang mass of fruit B is equal to 0.15 kilograms times ng kanyang final velocity is equal to 1.2 meters per second sine 38 degrees over mass of A, 0.11 kilograms times kanyang final velocity na na-solve natin kanina lang, ito, 1.33 meters per second. By calculating, ang angle theta natin is equal to 49.24 degrees. Kung gagamitin natin yung x component of the momentum, ipoprovide din niya yung same value for the theta. So, this is example number 2.